In this video we're going to use trigonometry to find unknown angles. So again, what we do is we draw the triangle, we label the sides, and then choose the appropriate trig equation. So the opposite, the adjacent, and the hypotenuse. Whichever one we're not interested in, we score out, and then that will help us pick from SOCA to which we're going to use. Whenever we substitute the known values into the equation, the unknown is with the trig term this time. So what we'll have is something like sine A equals 3 over 5, or it could be tan A equals 7 over 15, or cos A equals 15 over 31. And to get the angle on its own, we have to get rid of the sine, the tan, or the cos. And to do that, we can't divide by sine, we can't divide by tan, we can't take it away. What we do is we use the inverse function, which is sine to the minus 1, cos to the minus 1, or tan to the minus 1. And that's using the shift button on your calculator. So it will be the shift or possibly the second function, and then your sine, cos, or tan button. So in this first example, we've got our triangle drawn. We need to label the sides. So the side opposite the right angle is the hypotenuse. The side opposite the angle is the opposite. And the side beside the angle is the adjacent. And the side that we're not interested in here is the adjacent, so we're going to score that out. So whenever we go to SOCA TOA, we're going to get rid of the one that has the terms that have the adjacent. So that's Ka and Toa. So it's sine we're going to use. Sine is the sine of A equals the opposite over the hypotenuse. So that's the sine of x equals 4 over 7. So again, what we'd like to do is maybe divide by sine or something like that, but we can't, so we use the inverse function. So whenever sine goes to the other side, it becomes sine to the minus 1 of 4 over 7. So we go to our calculator and press our second function, or the shift button, and then sine, and we should see sine to the minus 1. Put 4 over 7, and then press equals, and we get that the angle is 34.85 degrees to 2 decimal places. Our next example then, first thing we need to do is label the sides. So the side opposite the right angle is the hypotenuse. The one opposite to the angle is the opposite, and beside the angle is the adjacent. In this case, we're not interested in the opposite. We know the hypotenuse and we know the adjacent, so we want to use them. So we go to SOCA TOA, and we get rid of the opposite. So that's so and Toa. So we're left with Ka, and that means the cos of A equals the adjacent over the hypotenuse. Put our information in, we get the cos of Y equals 7 over 11.5. Again, you'd want to divide by cos or take it away or something, but we don't do that. We do the inverse cos. So we do cos to the minus 1 of 7 over 11.5. And putting that into our calculator, we do shift or second function of cos. Cos to the minus 1 should appear. And then we do 7 over 11.5, and we get an answer of 52.50 degrees to 2 decimal places.